Hey everyone, today's lesson from Unit 9, Notes number 3, is all about slope. We are going to take a look at parallel and perpendicular lines, but really quickly, let's take a look at what you learned about slope in Algebra 1. So if you recall, slope is often referred to as a rate of change, or rise over run, or even delta y divided by delta x. That little triangle is the delta symbol representing change in something. But most likely, what you hopefully remember is that slope is equal to y2 minus y1, there's your change in y, divided by x2 minus x1, the change in x. So it's the rate of change between the y values and the x values. So we can find slope in a lot of different ways. You should be able to find slope between 2 points. If you just name one point x1, y1, and the other point x2, y2, and plug those values into your slope formula. So we have y2, which is negative 5. We want to subtract 3 from it. And we're going to divide by x2, negative 2, minus x1, which is 4. So negative 5 minus 3, or that's the same as taking negative 5 plus a negative 3, which would be negative 8. Negative 2 minus 4 is negative 6. If it helps, think of it as negative 2 plus a negative 4. We need to simplify this. Negative 8 divided by negative 6 is positive 8 over 6, but reduce it by dividing by 2 to get 4 over 3. Now, something important to point out is that it doesn't matter which point you refer to as x1, y1, and which point you refer to as x2, y2. Watch what happens when I switch the values. If I use the 3 first for y, I would do 3 minus a negative 5, divided by 4 minus a negative 2. 3 minus a negative 5 turns into 3 plus 5, which is 8. 4 minus a negative 2 turns into 4 plus 2, which is 6, and that reduces to 4 over 3. So it doesn't matter which one you use first or second. It does, however, matter that you use the change in y over the change in x, and that your points line up this way. Negative 5 and negative 2 go together, negative 3 and negative 4 go together. Okay. But you should also know how to find slope from a graph. And usually it's easiest if you start from the point furthest to the left. So if I start with that point, I'm going to count my rise and my run to get to that point on the line to the right. Okay, so the rise, I would come up 1, 2, 3, 4 squares. So a rise of positive 4, and then a run of 1, 2, 3, 4, 5, 6. So that means that our slope being rise over run would be 4 over 6, but that reduces to 2/3. Now, I went with the 2 marked points on the graph, and I'd just like to point out that you could also go from any 2 points on the line. So this is a good one because it's marked. This would be another good one right here. And notice that that gives us a slope of 2 over 3. And that's what we got when we reduced that fraction. Okay, before we talk about parallel lines and their slopes, I just want to point out that the 2 lines in this graph have negative slopes. Okay, in other words, the lines are falling to the right. So as you look at it from left to right, if the line's decreasing, it has a negative slope. Okay, so we want to take a look and compare these 2 lines. They certainly appear to be parallel. So I'd like you to find the slope of line segment CD, or in this case line CD. And we want to find the slope of line segment AB, or line AB, as the case is, because there are arrows here. So for line CD, if we're finding the slope, we want to find 2 nice points that we can find the coordinates of. And looks like we're going to have to count all the way from C to D. So we go down 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5. So it was -4 and +5. We went down 4 and to the right 5. Okay, calculate the slope for AB. So go from A to B. Again, we want to go down. That looks like 4 and to the right 5. So our slope of line segment AB is also -4/5. Right, these two lines are parallel. So AB is parallel to CD because they have the same slope. Okay, so parallel lines have the same slope. Okay, in our second example, these two lines are, well, at least they appear to be perpendicular, and we want to do something similar. Let's find the slope of line segment AB, or line AB. I keep calling it a line segment, but it's actually a line because of the arrows. So it has a negative slope. Count from A to B. Notice we go down 4. And then to the right 1, 2, 3, 4, 5. -4/5 for our slope. Okay, switch lines and take a look at the slope of line segment EF. So going from E to F, we want to go up this time because this line has a positive slope. And we're going up 1, 2, 3, 4, 5. And then to the right 1, 2, 3, 4. So this line has a slope of +5/4. Okay, if you compare these two lines, or these two slopes, okay, if you compare these two slopes, -4/5 and 5/4, they're what we call negative reciprocals of each other. So this fraction flips over. -4/5 is the slope of the first line. The slope of the line perpendicular to that has to be positive, and then you take the reciprocal, which just means that you flip the fraction over. So perpendicular lines have slopes that are negative reciprocals. Okay, so if you want to prove that two numbers are negative reciprocals, you can take them, multiply them together, and simplify. So if we multiply -4/5 times 5/4, we get -20/20, and it reduces to -1. That's just a way to prove that they are indeed negative reciprocals. All right, we have a quick CYU. That stands for Check Your Understanding. So let's see what you've picked up or what we have reviewed from Algebra 1 for you. You want to find the slope of the line that passes through the points. And actually I suggest that you pause the video, try all 6 questions, and then come back and check your answers. Okay, so number 1, it says find the slope of the line that passes through the points. So going from A to B, and so we need a rise of 2 and a run of +1. So our slope is 2/1, or just 2. Okay, and number 2, find the slope of each line. Are the lines parallel? So we have the slope of line segment, or line DC, and the slope of line EF that we're comparing. So DC, we're going up 3 and to the right 2. So its slope is 3/2. EF, up 3 to the right 2. So they are indeed parallel. They have the same slope. So, yes. Okay, because they have the same slope, they are definitely parallel. So DC parallel to EF. Alright, number 3, it says find the slope of each line. Are the lines perpendicular? Okay, so just be careful because sometimes we just take a quick peek and we say, hey, they look perpendicular, but actually take the time to find the slope. So for line GH, the slope would be -1 over +2, because I went down 1 and to the right 2. And the slope of line IJ, if we count it out, go up 2 and to the right 1, up 2 to the right 1. So I just double checked by doing it twice. 2 over 1. They certainly appear to be negative reciprocals to me. You can also, again, test it out by multiplying them. You get -2 over 2, which is -1. So yes, GH is perpendicular to IJ. Alright, number 4 says graph a line parallel to AB that passes through point P. So first find the slope of AB. So it's +2/3. We need to use the same slope. So starting at P, we want to count up 2 and to the right 3. There's another point on the line. It could have also gone down 2 and to the left 3, and then just connect those dots with a nice straight line. Okay, so parallel lines have the same slope. Okay, in number 5, we're graphing a line through point P perpendicular to line AB. So the slope of line AB would be 3 over 1. Our new slope, so that our line is perpendicular, would have to be the negative reciprocal. The reciprocal of 3 over 1 is 1/3, and so we have to have a negative slope so that it will go in the other direction. Alright, let's check this out. If we're going to graph it, we want to start at point P and use our slope, going down 1 to the right 3. Or you could have gone up 1 and to the left 3. And then just take and connect our points. I wish I had a ruler to make a straighter line. Remember that if your slope is -1/3, you could also do 1 over -3. Okay, for the last one, it says tell whether the lines through the points are parallel, perpendicular, or neither. So we just have to find the slope of line 1. And for that, we're going to take 3 minus 2 for the change in y's. So there's the 2 y values. We're going to divide it by 2 minus a -1. That's the change in the x values. 3 minus 2 gives us 1. 2 minus a -1 turns into 2 plus 1, which is 3. So the slope of line 1 is 1/3. For line 2, finding the slope, we're going to take 1 minus 0 and divide it by 3 minus 0. We get 1/3. So the lines are parallel. Lines are parallel because they have the same slope.